So there are many other types of real-life scenarios where exponential growth or decay occurs. We can model exponential growth and decay with these two formulas. E to the positive bx represents exponential growth. A times e to the negative bx models exponential decay. And one thing you want to keep in mind is in both of these equations, A equals the initial amount of any substance that might be growing or decaying. So in this first example, they're talking about a computer virus. The number V of computers infected by a virus increases according to the model V of t equals 100 e to the 4.0652 t, where t is time in hours. Find the number of computers infected after 1 hour, 1.5 hours, and 2 hours. So the first thing I'm going to do here is I am going to store V of t in my calculator, because if I'm going to plug in multiple values into this function, I don't want to have to do it multiple times, type it multiple times. So remember, we're going to store our function. So now we can answer each question. Part A is asking for V of 1. That's approximately 10,000.298 computers. Now, for computers, it really doesn't make sense to have a decimal amount of computers. So I would say 10,000 computers infected after 1 hour, right? We can't have a piece of a computer infected. Maybe in theory, but we're actually counting completely infected computers. Now for part B, we're finding V of 1.5. If I plug that in my calculator, I have 100,004.472. Now, once again, it does not make sense to have 0.472 pieces of a computer. So there will be 100,004 computers infected after 1.5 hours. And then in part C, they want to see how many computers are infected after 2 hours. So I just plug in V of 2 in my calculator. And that is, what is that going to be? 1 million. Let me make sure I have the right number of zeros. Yeah, 1,059 computers, 0.630. So for me, I would say we have 1,059 computers infected after 2 hours, because that 0.630 is not a full computer. Now, I just want to make a note. The textbook answer key says 1,060 computers because they round up. But to me, 0.630 is not a full computer. So it hasn't become a full computer that's infected yet. So I would accept either of these answers. Just know if you're checking your answer in the back of the book, it might have something different than what your mind thinks. So if you want to get the answer that's in the back of the book, use rounding rules to round up or keep the same. If you're using more logic, then you wouldn't include the decimal on the end. To each his own.